Welcome back to Math Maintenance. Today we are talking about comparing fractions. So when we want to compare fractions, we have a couple of things to consider. We have the numerators to consider, so how many, and then the denominators to consider how big of a section are we talking about. So when we compare something like 1/3 and 1/8, the numerators are the same. So then I have to think about how big of a section am I talking about. Here we're talking about having 1/8. Again, if I draw my pie, I only have one of those wedges. When I draw my 1/3 pie, I also only have one of the wedges, but since the pie was only divided into 3 parts instead of 8 parts, that one wedge is significantly bigger than the one wedge over here. When I'm comparing fractions, if they have the same numerator, the same top number, the bottom number is where I can look, and I just have to remember that's kind of backwards. I would normally think, oh, bigger number means bigger number. But in this case, the smaller number is actually telling us that the sections are bigger. So in this case, 1/3 is actually bigger than 1/8, even though 3 is smaller than 8. I have to think about the 3, meaning that I'm dividing my whole only into 3 parts as opposed to dividing my whole into 8 parts. If I think about another problem, here I have the denominators are the same. So the size of the pie piece, or the size of the section, so here's my whole, it's divided into 12. Here I only have one of the 12 parts. Here I have 4 of the 12 parts. In this case, because the denominators are the same, I only need to look at the numerators. Having 4 sections out of 12 is bigger than having just one section out of 12. So in this case, 4/12 is bigger than 1/12. So remember, when the numerators are the same, I compare the denominators, and actually whichever number is smaller is the bigger one, which is a little bit backwards. In this one, when the denominators are the same, the bottoms, I compare the numerators, and whichever number is bigger, that's the bigger fraction. But what do I do when the numerators and the denominators are both different? So here I have 3/6 and 4/12. Here I have 2/7 and 6/21. So the tops aren't the same, the bottoms aren't the same. I kind of have a mess. What you're going to want to do is to get it to the point where either the tops or the bottoms are the same. So I can look for, are there ways that I can make 3 into 4, or are there ways I can make 6 into 12? 6 into 12, I could do times 2 on the bottom and times 2 on the top. I would get an equivalent fraction of 6/12, and now I could compare that to 4/12. I'm using this rule over here because my bottoms are the same. Whichever top is bigger is the bigger fraction, which means my comparer goes this way, which means in my original problem, 3/6 is bigger than 4/12. One more to try. I have 2/7, 6/21. Can I make a 2 into a 6 or a 7 into a 21? I can make a 2 into a 6 by multiplying by 3. That gets me 6/21 compared to 6/21. Tops are the same, bottoms are the same, so these two fractions are actually equivalent or equal. In your packet today, you have a compare the fraction bucket activity. It looks like this. They've already drawn in compare signs in between. You need to decide if those compare signs are correct and color the bucket yellow. If they're incorrect, color the bucket orange. If you don't have those colors to color with, you can pick 2 other colors to color with, or circle the ones that are true and cross off the ones that are false. Somehow mark which ones are correct and which ones are incorrect. Your manipulative practice today is to continue practicing with those division flashcards. Like I've said in the past, if the multiplication is still a little bit rusty, keep practicing with those ones as well. Your digital practice for today is a fraction tug-of-war game. So follow the website link on Google Classroom to find that game online to practice your fractions. Best of luck.